This video is brought to you by mywayteaching.com.
So now let us solve a few problems. So the example 7. Determine the maximum acceleration of the train in which a box lying on its floor will remain stationary. Given that the coefficient of static friction between the box and the train's floor is 0.15. So we need to find the maximum acceleration of the train in which a box which is lying on its floor will remain stationary. And they have given the coefficient value. So we know that the static frictional force Fs is always less than mu s into n. Okay, since the acceleration of the box is due to the static friction, we can write the acceleration of the box is due to the static friction, isn't it? Yes, that is given by Fs. It is always less than mu s into n. We can write it in other words. N can be written as m into g. Okay, that is, by considering first and the last one, we can write A is always less than or equal to mu s into g. And now we should find the maximum acceleration, that is A max, which is given by mu s into g. So they have given the value of mu s as 0.15 and we know the value of g as 10 meter per second square. So the maximum acceleration is given by 1.5 meter per second square. Okay, here the acceleration of the box is due to the static friction, isn't it? So that static friction is Fs, which is given by mu s into n, where we can write n as mass into gravity, that is g, acceleration due to gravity. So by comparing those two equations, we get A is always less than or equal to mu s into g. And with that, we can find the maximum acceleration, which is given by mu s into g. And in the question, they have given the value of mu s, that is 0.15. Okay, using this value, we can find the maximum acceleration that is required. Okay, the acceleration of the train. So now let us consider one more simple problem. So you just see the figure, then only you can understand the question. A mass of 4 kg rests on a horizontal plane. A mass of 4 kg rests on a horizontal plane. The plane is gradually inclined until an angle of 15 degree. Okay, this plane is gradually inclined up to an angle of 15 degree with the horizontal. The mass just begins to slide. When it is inclined up to 15 degree, the mass, okay, which was there on this horizontal plane, it just begins to slide. Okay, what is the coefficient of static friction between the block and this horizontal surface? The question is to find the static friction, that is mu s. Okay. So initially this block was lying on this horizontal plane and then this horizontal plane is gradually inclined up to theta is equal to 15 degree. So when it reaches 15 degree, this block it starts sliding down from the inclined plane. Okay. So the question is to find what is the static friction between this block and the surface. Okay. The forces acting on a block of mass m. So we should consider all the forces which are acting on this block of mass m, which is at rest on an inclined plane, isn't it? So the first force is weight mg. So this weight mg is acting on this block because it is of 4 kg, right? So the weight mg acting vertically downwards. So and the normal force n of the plane of the block. So the normal force opposite to this weight. So the normal force is also acting, that force is given by N, isn't it? And the third one is a static frictional force between this block and the horizontal plane. There is a static frictional force, okay, which is opposing the impending motion. In equilibrium, the resultant of all these forces must be zero. So resolving the weight mg along two direction as shown, we can write it as, so we can, this mg we can resolve it into two components. One is along this vertical axis, that is given by mg cos theta, and this horizontal one, that is mg sin theta, isn't it? So we can, from this figure we can write the normal force N is equal to mg cos theta, isn't it? So as theta increases, the self-adjusting frictional force Fs also increases. So if you increase the theta, the self-adjusting frictional force Fs also increases until at theta is equal to theta max. Okay. This static frictional force achieves the maximum value, that is given by mu s into n, isn't it? We already studied this one. So we can write tan theta maximum is equal to mu s, or theta maximum we can write it as tan inverse of mu s. Okay. So we can write tan theta maximum is equal to mu s. And in other words, the theta max will become tan inverse of mu s, isn't it? Where theta becomes just a little more than theta max. There is a small net force on the block and it begins to slide. Note that this theta max depends only on mu s and it is independent of mass of the block. And I have given the value of theta max, that is 15 degree. So mu s is given by what? Tan of 15 degree, isn't it? So that is given by 0.27. So the coefficient of static friction is 0.27, isn't it? The coefficient of static friction is given by 0.27. So in this particular example, so we took the mu s, we need to find the coefficient, and we know the weights which are, or the different forces which are acting on this block, the horizontal force Fn, the normal reaction N, and the weight mg. We can resolve it into two components, that is mg cos theta and mg sin theta. So by those components only we'll get the value of that theta, that is mg sin theta by mg cos theta is equal to, so we know that mg sin theta is what? Yes, mg sin theta is nothing but the horizontal static. It is equal to static friction Fs, and mg cos theta is nothing but the force N. So we already knows that as theta increases, even Fs increases. At that theta is equal to theta max, Fs becomes Fs max. So that is given by mu s into n, isn't it? So we can write tan theta max is equal to mu s. Okay, from that we can get the value of static coefficient. Okay, so now let us consider the next simple problem is what is the acceleration of the block and trolley system, which is shown in the figure, if the coefficient of kinetic friction between the trolley and the surface is 0.04, and what is the tension in the string, and take g is equal to 10 meter per second square and neglect the mass of the string. So this is the trolley block. So now we should find the acceleration of this block and trolley system. Okay, and they have given the value of, yes, the value of kinetic friction between this trolley and surface, that is Fk, that is given by 0.04. So we should find the tension in the string, and even they have given g as 10 meter per second square and the tension in the string. Okay, so here we have considered the free body diagram at the point W, here W, and there is a T, the force T, and then the weight W which is acting on it. And at another point we can consider the tension T and the kinetic friction Fk, isn't it? So at this point is the first free body diagram, and at this point the second free body diagram. Okay. So as the string is inextensible and the pulley is very smooth, the 3 kg block and 20 kg trolley, this 3 kg block and this 20 kg trolley both have the same magnitude of acceleration. So applying the second law of motion to this block, okay, applying the second law of motion to this block, we can write 30 minus t is equal to 3a. Okay, the force, the change in force, that is 30 minus t is equal to 3 into a, where 3 is mass and a is acceleration. So applying the second law of motion to this trolley now. So that is given by t minus fk. So T minus Fk is nothing but the mass is 20 and A, isn't it? So now we know Fk is equal to mu k into N, where mu k is 0.04, isn't it? We know that Fk is equal to mu k into N. So here they have given the value of mu k, that is the constant value, the coefficient value. So here we can write mu k is 0.04. We know that, isn't it? And n is equal to 20 into 10. That is m into g, which is given by 200 Newton. So thus the equation for the motion of the trolley becomes T minus Fk is 0.04 into what? N is what? 200, isn't it? That is equal to 20 into A. Or in other words, we can, after simplifying this, we get T minus 8 into t minus 8 is equal to 20a. So this is the one equation and the first one equation is here. So these two equations we got. So using these two equations, we can find the value of a as well as t. Okay. So the first equation was 30 minus t is equal to 3a, and the second equation what we got is t minus 8 is equal to 20a. Okay, these two are the simultaneous equations. So we can solve these two simultaneous equations directly since there is minus and plus sign. So this t and this t get cancelled, and 30 minus 8 becomes how much? Yes, it is 22 is equal to 23a. So the value of a will be 0.96 meter per second. So if you substitute the value of a in the any of these two equations, we can get the value of t, that is given by so the value of T will be 27.1 Newton. Okay.